Hello, everybody. So today we are going to talk about architecture in object-oriented programming, and we are going to do a case study. I'm going up. So what is in fact often done and what we've already done in the Python workshop is to explain the basics of OOP. So Mathieu did it. So to explain the syntax of a class, subclasses, method, attributes, and so on. And also to give general principles of clean programming, for example, the solid principle, as I did, I think, 1.5 months ago. But typically, when we do that, we use very simplified examples, and sometimes they are a bit artificial, and it's a bit, yeah. When you arrive in real life and with real problems, it's not always obvious to see the correspondence with the principles and so on. So what I would like to do today is to take a slightly more realistic example, although in fact my example will be itself simplified compared to the actual problem I was dealing with, based on my personal experience. And we will, in fact, it will not be so obvious to identify exactly the programming principle that we are going to use to say, oh, okay, it's principle A, principle B, but it's more general reflection about the kind of bad thing that can happen if you take bad decisions about the architecture. And so, yeah, we are going to deal with, I would say, the spirit of the principles rather than their letter. A few words of caution before beginning. So, as I said, these examples are related to my personal experience. So they are not as universal as didactic examples that are aimed to be able to speak to everybody. And a second word of caution is that, of course, when we do software architecture, we always make a series of choices, and it's not always black or white, good or bad. And maybe in the course of this talk, we will not agree on everything. But I think that the interesting part is to discuss about all this, try to understand in particular the consequences of our actions, of our architecture decisions, to be able to make more educated decisions in the future. And this session, for once, I will try to do a real interactive session. So I will take your ideas, and please don't be shy, even you on the bridge, because I'm going to ask a lot of questions, and it will be very sad if I am the only one to answer the questions. So the case study for today will be the design of a package to implement voting rules. So people who know me know that it's my stuff, and it's based on my experience to code a package that is called Walrus with an H, for which alternative represents us, and that you can find on GitHub if you're interested in seeing the differences between the simplified version of the problem that I present today and the actual version of the problem that I use. So this talk will be in two parts. The first part will be about how we implement the ballots of the voting rules, and the second part will be about the voting rules themselves, so which take the ballots as input and that output a winner. So to design our package, we will need to have several kinds of ballots. So for some voting rules, we might need orders that can be weak orders. So for example, D is equally preferred to B, and they are both preferred to A, and and A itself is preferred to C. We can also deal with linear orders, where there is a strict total order on the candidates, like D, B, A, C, for example. We could also need grades for certain voting systems. So for example, D has a grade of 10, B has a grade of 7, A has a grade of 1, C has a grade of 0. And maybe during the course of the project, we will see that, in fact, we need also other kinds of ballots to represent the preferences of a given voter, and to be taken as inputs in the voting rule. So we need to keep in mind that that there are possible extensions of our package during its life, and that we need to foresee the fact that we might need to add some features in the future. So the first question that we might ask is, are we going to use classes or not to represent the ballots? So there are essentially two options. The first one is not to use classes, because not everything should be done in an object-oriented way. So, for example, for possibly weak orders, we can say, okay, it will be a list. So what is before in the list is preferred to what is later in the list. And if I have indifference between several candidates, I will put a set of candidates. So here, for example, this format would mean that, okay, I have an indifference class containing D and B, and these candidates are preferred to A, which is itself preferred to C. For linear orders, it would simply be a particular case of the previous one, but okay, it's just a list of candidates. And for example, if I need a ballot with grades, I can use, for example, a dictionary and say, okay, for each candidate is a key, and each value is the grade that is associated to the candidate. And the second option would be to make classes for each possible type of ballot. So we would have, for example, a class ballot order, maybe a class ballot linear order for the ones that are strict total orders, maybe another class called ballot grades, and maybe other class for future kinds of ballots. So that's the time where you prove that you are not sleeping. What would you recommend? And the most important thing is, why would you recommend what you will recommend? Shoot. Who shoots first?
So the bad guy will say no class for speed and just use type to infer the thing. But you need a contender at some point.
Yeah. You're a nice guy. In fact, you're nicely the bad guy.
I will also the first one, but not for speed, but for simplicity. Even though it can limit readability, because if you say to the user, I expect a list or a dict, well, it's not as clear as say I expect grades or linear order.
Okay.
Me, I would go for classes. Do you hear me?
Yes.
So I would go for a class-based implementation of ballots. And if there should be an order or grades, I would just overload the comparison operators.
Okay.
And just work with ballots and usual signs.
Okay. So I had put 3 asterisks, but if you have more ideas, you can continue shooting. Mathieu, you seem to be about to talk.
Yeah, maybe it depends if you have methods to implement to your ballot order, ballot linear order, that is not already implemented with the built-in methods in dict or list, for instance. So I don't know if you have specific, if you want to extend your capabilities, maybe you want to make a custom class.
Okay.
It's never a good choice to class dict.
So some people might say it's a dangerous idea.
What I think also is that if you want to transform a ballot in another class of ballot, so classes may be required in that.
So if you want to do ballot conversion from one type, okay.
Maybe.
In the end, the big question is who will be in charge of the dispatching of the ballot type? Because if you know that there is one single point of handling the ballots, maybe it's better to use that single point.
Yeah. Okay. If you handle ballots in a single place.
Of course, you're going to be sure that it will stay single, whatever notification if you can do it. So it can be some stretch.
Okay. Okay, so we already have a lot of ideas. So let's go with option 1 to start with. So if you choose option 1, in fact, you will probably need a function to do several things on ballots. So I will only take 2 examples. The first one is to display a ballot, simply to convert it into a string. And the second one is to extract the top candidates of the ballots. So here, this function would look like this. The details are not very important, but essentially, I say, okay, if it's a dict, then blah, blah, blah. I construct my string. If it's a list, then blah, blah, blah. I do something else. And in the other case, I raise an error. So just checking that it works. For a ballot that is a dictionary, okay, candidate D grade 10, candidate B grade 7, and for one that is a weak order, okay, B is like D, who are preferred to A, who is preferred to C. Okay, so it works. And now, if I want to extract the top candidate of a ballot in the same way, if it's a dict, then I get the max grade, and then I essentially take the argmax of the dict. And if it's a list, I will take the top equivalence class, and then I will be careful because it can be either a candidate or a set of candidates. So I will dispatch what I need to do accordingly. So once again, it works and does what I want. So seeing that what we saw now, do you see some drawbacks to the approach that you hadn't seen before?
I mean, if you were to print the ballot, you would have to call explicitly the ballot method instead of using, the convention.
Okay.
The magic method.
Right.
And also the readability. If you write this, if you do the dispatch with E instance and so on, but in this case, you could use the single dispatch algorithm from output to every maybe.
Another issue that I see is that the code is very small and there's already a lot of if, else, if, else, if, else, if. Like more than half the code is if, else, if. That's a very bad sign.
Yeah, I totally agree with Maxime, and in fact, the more you are going to write in this project, and the worse it's going to be. You will have if and then everywhere, and it will just be a mess. Other ideas? Okay, so essentially, I agree with what we said. For me, I will tell you my ideas. First, later in the project, if you want to add another type of ballot, you will need to search everywhere in your project which functions do this kind of if, else, if. And if you miss one, in fact, you will have a bug because there will be a case that will not be covered. So it's just a hell to maintain your project. The second reason is that sometimes, in fact, the type of ballot may not be easily recognizable. Because consider the first one. The first one is not the worst, verbal evaluations. So instead of giving grades, you say, okay, to each candidate, I assign something that belongs to a scale of verbal appreciation. Naturally, you will represent it by a dictionary, but this dictionary doesn't have the same meaning as the kind of dictionaries that we had before. So if you are looking for an argmax in that, you will find, in fact, the best evaluation by alphabetical order, and that's probably not what you want. Even worse, if you take, for example, partial order from the top. So I prefer D to B to the others, which does not mean that I prefer D and B to the others. It just means that I didn't want to tell my opinion about the others. or partial order from the bottom. So C is the worst, then A, and I don't want to tell my opinion about the others. Naturally, you would tend to represent this kind of ballot as lists, but these lists are not interpreted the same way at all at the list that you used before for weak orders or for linear orders. And in fact, from the type of the internal representation of the ballot, you cannot deduce what is meant, in fact. And that you can only know if it belongs to a class. Next consequence. Okay, for the moment, I consider that my candidates were strings, but why not allowing candidates to be any kind of object in Python, or at least any kind of, let's say, immutable and hashable object to avoid problems. So imagine now that you have a preference over sets. Okay, so you prefer the set AC, then the set AB, then the set BC, for example. You will naturally represent that by, I prefer the set AC, then AB, then BC. If you put that in the previous code, it will understand that, in fact, you are indifferent between A and C, and then you prefer that to A, and it just makes no sense. And of course, all these problems are easily solved if you choose the option with classes. So I partially agree with Fabien on the fact that if you really and totally know what you do and what you will ever do in the future, maybe you can stick to basic types and say, okay, I know that a list represents a total order and I will always treat it accordingly and so on. But in fact, if you want any kind of maintainability and extendability in your project, class is really the way to go.
I think the distinction is that here, everything you say makes sense, the project or package, but I think that the simplest option is better. Like if you just do a notebook, right? Simple script. Sometimes it's better not to go. It's tempting to try to model everything with class, but sometimes it's better to start, I think, with something very simple. But then I agree that when you want to scale it,
yeah, sure. But to my defense, I was clear on the context. We are designing a package.
Okay.
And I was really clear also on the fact that we might need other kinds of ballots in the future. It was in my assumptions. Okay, so now let's discuss about how we are going to organize things into classes. So who is a subclass of who? Generally, you would probably think that it's a very simple question. And in fact, it's not so clear. Sorry, I see a message in the chat. Classes to overload the, okay. Okay, so just temporarily, we are going to just consider ballot grades and ballot order. So ballot order, which represents orders that can be weak orders. I don't impose linearity here. So according to you, which one should be the parent class and which one should be the child class and why?
Do you want to start with the right answer or do we start?
As you like.
So assuming you have these two cases and only these two cases.
So there is probably a parent class like ballot, huh? But among these two, which should be the child class or the other, or maybe
if there is a upper class ballot, I say
exactly. So first possible answer, they should be independent subclasses of ballot. That's a possible answer.
Otherwise, if I remember the solid principle correctly, ballot grades should be a subclass of ballot order in the sense that if you've got a grade, you can do all the things you do with order. But maybe there is a way to say it's the other way around. It's LSP.
Yeah, list of substitution principle.
Okay.
Okay, other ideas?
There are principles that allows to do the reverse way.
Yeah, which other principle?
To do it in the other way, but I don't. I think it is opposite to.
But what would be the reason? Maybe
the reason is that you in grades you have more information than in order. So if you reason by this, I don't know if there would be. I'm not enough Python familiar with Python, so Python, but for me, because there is more information, that it can be a subclass.
That is essentially consistent with what Fabien said. So you said that grades should be a subclass of order.
No, the contrary. Ballot order grades. I know, sorry.
It's like complexity reduction, as always.
Sorry, it's a mess in my head. What I say, I do not understand so very well what Fabien said, sorry. But for me, more information is a subclass.
Yeah, you add some function, some feature in some sense.
So it is.
It should be able to do whatever the upper class is able to do.
Okay. So I agree.
Okay. Other ideas or opposite opinion? Does somebody think that ballot order should be a subclass of ballot grades?
I agree with it. I would just add that I would keep a somehow abstract class, even if they don't really exist in Python, of ballot for readability and purpose. So we remember what ballot is about.
Yeah. I think we agree that anyway there should be
that somehow, ballot should be abstract.
Yeah. I think we can all agree on that.
Yeah, because there are many ballots that you can convert into a ballot order, but as you say, it's not the case for all.
No, not necessarily. No.
Sorry, maybe you said this.
Okay. Okay, so let's go. So on my side, I listed some more or less good arguments. So the first idea to say, so the parent is ballot grades and the child is ballot order. So it's the opposite of what you said. Okay. Why could we say that? Because internally, when you want to represent a weak order, in fact, a very easy and natural way to represent a weak order is to represent it by a dictionary of artificial grades. So you say, for example, okay, D and B are in front of two other candidates. So I give them the grade 2. A is in front of one candidate, I give him the grade 1, and C is in front of 0 candidate, I give him the grade 0. And naturally, it's very easy to manipulate such a dictionary to know all that you want to know about the weak order. If you want to know, for example, later if a D is preferred to C, then you just have to test whether the value associated to D is greater than the one that is associated to C. So it's a very convenient representation of a weak order. And the second argument, ballots with an order give less information than grades, so it is a subset of ballot with grades, and it should be a subclass. Yeah. I admit that this argument is really bad. And so the option 2 is to say that ballot order should be the parent and child should be the ballot grades. And in fact, it's totally that. The good reason amounts to the list of substitution principle is to say that, okay, all that you can do with the partial order, you can do it with a ballot with grades. So if you say that the ballot with grades is a subclass of ballot with orders, you won't have any problem, because at any place where you could use a ballot with a weak order, in fact, if you put a ballot with grades, there is an obvious conversion and an obvious way to use this ballot with grades as if it were a ballot with a weak order. Chick. So just since you are very clever, you only gave arguments for the good solution and not for the bad solution. But anyway, I will develop on the bad solution just to show that Liskov substitution principle is not only a theoretical thing, but really something that will cause problems if you don't respect it. So here, for example, so I didn't put the parent class ballot just because for the sake of a brevity of the example. Here, so I have ballot grades, where I store a dictionary of grades, and for ballot order, I subclass ballot grades. So the bad idea. What I enter in the init is the list of the equivalence classes. I register this object in the corresponding attributes. I compute a dictionary, like I said before, that represents the weak order, and then I pass it to the init of the parent class. If I use this, okay, dbac, it does what it's supposed to do. So b2, d2, a1, and c0. So up to now it works. Now let's see the consequences of our choice. If I want to implement, for example, range voting. So range voting is a voting rule where you simply do the sum of the grades that are assigned by the voters to the different candidates. So to do this, I can use the counter from the collection, comment on dit ça, package, mais library. And then if I use this range voting with 2 ballot grades, it's going to work. D is going to have 20 points, B is going to have 14 points, A is going to have 2 points, and C is going to have 0 points, okay? But now nothing prevents me from using range voting with a ballot grades and a ballot order, because ballot order is a subclass of ballot grades in this option. And then I will find, for example, that D has a score of 12 because it's 10 for the first voter, and it's my artificial score of 2 for the second voter. So in your opinion, what should be inside the result in that case? Ideally, is it reasonable? Are we happy with this result, or what would you expect? Okay. So according to yeah, I translated your answer into error, but
so intuitively you give less voting power to the second voter.
Yeah.
And more generally, you need specific conversion rules.
Yeah. Sure. Ideally, you would not have the right to write this, and if you do, it will raise an error. Of course, if here you add, for example, a conversion rule between the ballot and what you do, there is no problem. But writing things like this should raise an error. In fact, you don't want that to pass without warning the user, more than warning. Blah 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 blah. And also a second problem is that these results. So first, it does not make sense, but also it relies on an implementation detail. So if one day you want to represent your weak order by other scores that are also represent the same weak order, in fact, it will change the result, because whereas it shouldn't. So now if we are looking on option 2, so since you're already convinced, I will be quick, but okay, for the ballot order, you record the equivalence classes. Here I only implemented a property just for the example that is next, of extracting the top candidate. And then for the ballot grades, you inherit from ballot order, you register the grades, you deduce the equivalence class, and of course, ballot grades will inherit for the method that will find the top candidates. Sorry, not the top candidates, the top candidate. and just sorry to finish with the example. In fact, so it's the top candidate singular, which means that if there is only one person, if you in your top equivalence class, it will return this person. And if there are several persons in your top equivalence class, it will return none. Which is just a detail, but it's important for the example just after. And so now if I want to apply a plurality voting, for example, so plurality voting just means that you vote for your most liked candidate and you give one vote to your most liked candidate. So it's the usual uninominal à un tour in French. So for each ballot, you check the top candidate and you give this candidate 1 point. So now if I apply plurality voting to a ballot order here with two favorite candidates, one ballot order with one favorite candidate, and this ballot with grades with one favorite candidate, in fact, it will say, okay, C got 1 point from this voter, D got 1 point from this voter, and in fact, this voter gave points to nobody because it does not have a well-defined favorite candidate. Do you find it reasonable so far?
It's priority, so
Huh?
it's priority. So
Yeah, the voting rule itself is not reasonable, but from a coding point of view. Yes, you with me? There
may be a problem about defining top candidates for some types of ballots, like partial orders.
Yeah, but in fact, so here I didn't write the type hints, but if I would, it would be this one. Okay, so which means that everything that is capable of being seen as an order is allowed, and in particular, grades are allowed because I can interpret grade naturally and without any arbitrary choice as an order. You see what I mean?
Yeah, but we need a strict order to find the top.
No, sorry. That was the sense of the assumption that I did before.
Ah, yes, sorry.
That if you have several favorite candidates, then you give your vote to nobody.
Okay.
But
yeah, then it works. Yeah.
But indeed we could limit it to strict orders if we wanted. Answer to my own questions. So now let us test range voting is in this second good option. So I didn't have to change the implementation. In fact, it works as it was. So now I take a voter with ballot grades here and a ballot order here. So now it indeed returns an error, raises an error, which is what we wanted, because it's stupid to use the second ballot without explicit conversion to grades. A side remark, in fact, for implementation reasons, as I said, it can be convenient to represent weak orders with pseudo grades, because just very convenient to test, for example, if one candidate is preferred to another one, just have to test two values in a dictionary. So what you can do, for example, is to say that when you have a ballot order, in fact, you will have these, let's say, hidden attributes, which is a dictionary that to each candidate assigns a pseudo grade in the way that we did before, and which will help you implement, for example, these functions strictly prefers that is able to test if you strictly prefer a candidate to another one, because you just have to test the two values in the dictionary. So you could have to do that, but remark that here, in fact, it's a private attribute. So I don't guarantee in the API that it will work exactly the same way in the future, and so on and so on.
So, for instance, the ballot grade inheritate the pseudo grades.
Yes. In fact, yes. So actually, in the real package, it's done a bit differently to avoid this double dictionary thing.
So it's not exactly a subclass, or because you cannot.
Yeah, ballot grades is a subclass of ballot order, but in fact, if you in this implementation, if you ask to a ballot grade, do you strictly prefer candidate A to candidate B? It will not check in the dictionary D candidate grade, but in the dictionary D candidate pseudo grade, which is slightly stupid because you need to construct a second dictionary before looking for the information that you want, whereas you could have simply looked at the first dictionary. But in fact, if you want to avoid that, there are many solutions. One of the solutions would be, for example, to override D candidate pseudo grade to say, okay, in the case of a ballot grade, in fact, it's the same, it's exactly the same as a D candidate grade. So here the example is a bit simplified, and this problem can be easily solved. So here are examples that indirectly rely on these pseudo grades. So here I have a ballot orders. I ask if you strictly prefer D to A, and it does what I told. And here the same for ballot grades. And final remark. In fact, what we can do also is to choose standard pseudo grades, like for example the Borda scores, which are a classical notion of score in voting theory. And in that case, you can even make it part of the API, in fact, because it's really something that you want to maintain in the future. And in that case, you can write it without a leading underscore. Okay, what time is it? I think we're good. Yeah, very nice. So now what about linear orders? So remember that for the moment, we have solved the problem for ballot order, which is the parent class, and ballot grades, which is a subclass. Now, a linear order is a particular case of ballot order where all the equivalence classes are of size 1, in fact. Do you think that it should be a subclass of ballot order? Do you think that it should even be a subclass of ballot grades? Do you think that it should be something else? Tell me.
Well, following the LSP principle, ballot order should be a subclass of linear order. If I apply the same principle than before.
Donc toi tu dis ballot. In fact, so ballot linear order should be at the top of the hierarchy in some sense.
Yeah.
Okay.
Let's be bold.
Okay. Linear order should be above ballot order.
Because order is above grades.
In the hierarchy.
I would say the opposite.
Okay.
So I would put
copy paste. For what
exactly.
reason? For what reason exactly?
Because it's a particular case, so we can re-implement plenty of methods with different calculations in a way. But when you have a particular case, it's a subclass.
So we have to see the difference with order grade discussion and let's be principle.
What is the difference?
Yeah,
so it's a good question. That's why I think this example is interesting. Okay, other ideas? Intuitions? Okay, so let's have a look. So from the point of view of LSP, the question is what you do with the linear order, can you always do it with a weak order, and vice versa? Okay. So, for example, if you want to take the top candidate and if you want that it returns a unique candidate, you have the specification that it should return a unique candidate, then it works for a linear order, but it will not work for a weak order. Okay.
It's kind of specious to say, okay, this is the specification I will use.
Yeah, but in fact, in that case, it's quite simple because linear orders are really a subset of weak orders. Okay, so in that case, in fact, there is no real question. If you want it to be a class, it really should be a subclass. So it's there. By the way, I will write it the other way. Should be a subclass. Sorry, but in order should be a subclass of ballot order. So just rephrase what was written. So if you want it to be a class, clearly that should be this solution. Okay. And as Maxime said, in fact, there are some specific methods that you will be able maybe to optimize for linear order because you can exploit the particular structure of these particular cases, which is just particular cases of weak orders.
By the way, so it will be probably a bad idea, but it's something I do sometimes.
Yeah.
You kind of hint in that direction. You can have an attribute is linear, and so you can use that, for instance, to tell if something is already sorted or not. But you kind of get the hint.
Okay, so let's have a look at all this. So in fact, here, so in the following, I will not go more into this option because it's clearly excluded by LSP, but I will have a look at the second one. So Maxime's option, let's assume that linear order is a subclass of ballot order. Sorry. And in fact, we don't care if it's a subclass of ballot grades or not. Excuse me. So now I have my class ballot order. Okay, so when I have a ballot order, I register the equivalence classes as usual. And I have my class linear order. And when I input a ranking, which is a list in that case, okay, I register the ranking somewhere. I deduce the equivalence classes and so on. So if I enter a ballot like DBAC, the equivalence classes will be singleton D, singleton B, and so on and so on. So it works fine. And then let us implement a positional scoring rule, for example. So the principle of a positional scoring rule is to assign a weight to each rank. So for example, for the board account, it's n-1 for your preferred candidate, n-2 for your second preferred candidate, and so on. But you can imagine all the weights that you want. And then I will apply this to two ballots with linear orders with the weights 4, 2, 1, 0, which means that the first voter, for example, gives 4 points to D, then 2 points to B, then 1 point to A, then 0 point to C, and similarly for the second voter. So it works. It's okay for you, I guess. Yes.
Sorted, but
yeah, you can resort it if you want. And then if I do that, so it's essentially the same, but the second ballot, instead of explicitly specifying that it was a ballot linear order, I just give a ballot order which happens to be a linear order. And in that case, it will not work because my ballot order object has no attribute ranking, in fact, and I relied on this attribute ranking to make my scoring rule work. Okay. Maybe you will agree with me or not that it's a pity that it doesn't work. So if you really want to be a Nazi about syntax, you could say, okay, people are responsible for themselves. They need to give me something that is explicitly a ballot linear order. And if they give me something that is a ballot order, which happens to be a linear order, too bad for them. I just don't care. That's not my problem. You can do that, but you might want to be a bit nicer than that. Another thing, yeah, similar example. Here, my first one is explicitly a ballot linear order. My second is a ballot grades, which happens to be, in fact, a linear order. And similarly, it doesn't work. So here again, it's not unreasonable, but it's a bit sad. So maybe I will go quickly on that because Fabien already mentioned the solution that no, it's okay. So my personal choice would be the following, but I don't pretend that it's the only one. It will be to implement, in fact, a property or of a ballot order, which tests whether it is a strict order or not. And if it is a strict order, then you can compute the ranking and so on. So it's a bit debatable because you lose type hinting and you lose a bit of list of substitution principle and so on. But in that case, personally, I find it quite convenient because if you input something reasonable into your function, your function will be able to deal with it and just do the job that you probably wanted to do. So if I do it like this now, if I use my positional scoring rule with the ballot order and ballot grades that happen to be a linear order, then it will work. I'm sorry, I accelerate a bit. Okay, so now we have a few minutes to talk about voting rules, but it's okay because really the main part of my talk was about the ballots themselves. About the voting rules, so essentially, just quick mental picture. Your voting rules take ballots as input, and they output something. So the list that they can do is to provide a winning candidate. And very often, in fact, they're also capable of assigning scores to the candidate, maybe rank the candidate, so provide an aggregated ranking of the candidate for the whole population. And that's it. So what would you envision as a general architecture for the voting rules?
First question is
Sorry? Yeah.
It's more questioning, should the ballots be in the init or somewhere else?
Okay.
I don't remember the solution.
What do you mean?
I mean, different voting systems will fit with different types of ballots. So if you want to use the kind of under the carpet of the solid principle, usually you use the init to hide the fact that your signatures can be different things.
Okay, I see.
But
It's not clean to give data in the init.
I kind of agree with Maxime, and I will write it, by the way. It is not morally acceptable. In the init.
And another question is there relationships between the voting rules, and can the voting rule be a particular case of another voting rule or not?
Okay. be a particular case of another voting rule. So which essentially amounts to say, is it relevant to do classes in order to benefit for inheritance? Yeah, that's a good question. Other reflections, intuitions,
And
flashes of genius.
with your we'll have special behaviors, like I'm going to if it's just a function, if it's just you have an input and you want an output with some kind of parameters. It's not the same thing if you have special methods that you want to act on the data. So it depends on that if you want to use a function or a class.
Yeah, I'm not sure.
I think if you have this need of private method and so you want to use.
I think he says maybe a function is enough.
Maybe function what?
Maybe a function is enough to do that.
And also, I'm just thinking it depends if that's if the voting rule is the last thing the user will do, or it will create voting rules and give them to other functions or whatever, right? And
it's never the last thing that you do.
Okay. In this case, maybe you want to.
Nothing is ever the last thing that you
also want to group them like voting rules that return single value, voting rules that return multiple winners.
Okay. 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 So yeah. Essentially, first there are two options, two very general options. The first one is to use functions, and the other one is to use classes, functors, as would Marco say. So let us explore the first option. So as usual, which I think is the bad one. So the input will be a list of relevant ballots, and the output should be something. Winner, scores, ranking of the candidates. I don't know yet. So we could say, okay, we are going to return the scores because the scores convey the most information. Once you have the score, it's easy to extract the global ranking of the candidates. It's easy to extract the winner. So let's return the score. So, okay, I have a function for some voting rules, some voting rule, blah, blah, blah. I compute the score in some way, then I return the scores. And then I have other functions like one function that takes the scores and output the winner, one function that take the scores and output the global ranking. And then I can compose these functions in the way I want according to the kind of thing that I want. So of course it will work more or less, but the problem is that not all voting rules rely on the score. So how am I going to do? Should I output the winner in that case? Maybe, but in that case, if I want, for example, to loop over a set of voting rules and test different stuff on it, in fact, I will have a problem of a type compatibility. So it's not very good to do like this. So second option would be to return the winner. So if I implement, for example, a scoring rule that way, I will say, okay, internally in my function, I compute the score, then I deduce the winner, and so on, and I return the winner. But it's stupid because I lost the scores, in fact, whereas I computed them and I don't have access to them. So of course, I can say, okay, I will return a composite output, like a dictionary, for example, and say, okay, if I have a score, I put score in the dictionary. If I have anyway, I will have a winner. So that's the only key that I'm sure of finding in my dictionary. And if I have other kind of information, I will put them in that. Frankly, I don't like very much that option for several reasons. The first one is simply that you lose autocompletion, for example, and you essentially don't know what there will be in your dictionary. And so
you return the dict, but you can return a class, right?
Thank you very much. So the next option is to return an object of a custom class. And here, for example, a simplified version of this could be to say, okay, I can give a winner, scores, ranking, or part of this information. And then, so here I use the decorator cache properties from FuncTools. And I say, okay, the scores are the scores, otherwise there is a problem. But for the ranking, if I have explicit ranking, I return them, and otherwise I will deduce them from the scores. And for the same for the winner. If I have a winner, I return it. If I have a ranking, I return the first member of the ranking, and otherwise I deduce the winner from the scores.
And just to mention, this could be a good use case for data class. This kind of class where you have immutable data in it, and
Yeah, why not? Why not?
Yeah.
Yeah, it depends a bit if you want to compute all these attributes during the post init,
Yeah.
or on the fly. I do here, as I do here. So that's an option. It's not.
Question on this.
Yes.
Maybe there is something I do not understand in Python here. If you have both winners, all the things.
Yeah.
When you will try to find the winner, it will. I mean, there is return. Sorry.
Yeah.
There is return. So
Okay. In fact, it's the problem of doing a RISE presentation that I want to keep my code short.
Okay.
So I never do that in real life to put the conclusion of the if on the same line. I only do it when I need to fit in one slide.
No, it's okay. I do the same. Don't worry.
But don't do it at home. It can hurt. Okay, so you can check it works, blah blah blah. And yes, it's essentially it works. So it's not a stupid solution. Personally, that's not the one I prefer. And the one I prefer is to do classes for algorithms, because you can benefit, for example, from inheritance. And just an example, so you don't really have voting rules that are particular cases of one another, but what you have is voting rules that belong to the same category and that share a piece of their mechanism. And the simplest one is simply all the voting rules that have scores have this very simple mechanism to decide the winner, take the argmax of the score. So that you will just put it in a method that will be inherited by all your scoring rules. And similarly, in fact, you have many, so you will have a whole tree of voting rules. So all the ones that use a score, all the ones that compute the score in a particular way, let's say, and so on and so forth.
And
A tree or a DAG?
It's a tree.
Oh.
Yeah.
And if condorcification, it helps also, I suppose.
And in fact, for anything that you will do, it helps, because you will always be able to say, okay, these operation that I want to do on a voting rule, for example, a transformation of a voting rule to make another voting rule, I need a voting rule of a specific class, for example, or I need any voting rule and it will work. And it will very, very easy to say if all this is organized in a tree of inheritance. So, of course, I will not develop this solution today. It was the subject of a talk that I did at the very, very beginning of the Python workshop that was called Some Architectural Consideration for Algorithms in Python. So if you're interested, you can see. But essentially, I heavily rely on house implementation of cache properties. So this is it here. So it's but at that time, it was not in functools, by the way, but the implementation is slightly different. And in particular, I have this mixin that allows me to delete all the cache of an object when I want to do it, and it's useful for me. And then, in fact, it's very, very, very convenient to use because, in fact, in the init, you will have the parameters of the voting rule, so the general parameters. In the call, you will have really the input, so the ballots themselves, and all the intermediate results that you want to compute, you do it with cache properties. And it's very, very convenient because it's very easy to subclass each way of doing the intermediate result. So for example, here, so the only thing that a rule needs to do is to be able to compute a winner, but a priori it's not implemented. Then if I have a rule with the score, the only thing that is sure is that to find the winner, you need to find the argmax of the score, and the score itself is not implemented. Then if you want to implement, for example, range voting, the only thing that you have to do is to simply implement the way that you compute the score, and everything will work automatically.
I find cache property dangerous with mutable class. I mean, if you forget to call delete.
So in fact, what happens here is that, sorry, yes, I forgot to mention here. So when you want to give ballot to your voting rules, in fact, it's done in the call, and the call is written once and for all in the parent class. And what the call will do is to say, okay, I delete the cache because, of course, I need to forget everything about what I did before with the old ballots. Then I store the ballots in an attribute. I return self, and I don't do anything. And that way, as long as you don't ask something like the winner, the score, whatever, it doesn't compute anything. And if you ask, for example, for, let's say, the scores, it will just compute the score, but it will not compute the winner. It will not compute the ranking of all the candidates. For example, you make the economy of sorting a list, for example. And so it's extremely lazy. And in fact, you cannot really forget to delete the cache, because it just written once and for all in the parent class.
So just one more inconvenience I see is that it's not that safe, in the sense that if you were to use the same rule in parallel,
yeah, exactly,
you will need to instantiate it in each thread and don't reuse the same rule.
Exactly. The only limitation, I totally agree with you, is that if you want to use it in parallel, you need to copy the rule for each thread. Otherwise, you will have big problems. Exactly. Yeah, that's the main limitation. Just have to be careful about that. And in fact, another solution, and I come back to what Fabien said, would be to say, in fact, my class is not for a rule. My class is for an election. And in fact, in the init, I give the parameters and the ballots, and it's immutable. And my object is immutable. And each time you want to do an election, you create a new object, which has the drawback that the advantage of this version, of my version, is that it's very easy to define a rule with all the parameters, with a long list of parameters, and then to use it on several elections. If you have elections object instead of a rule object, you need somehow to store the parameters in a dictionary, for example, and to feed them to each election object that you are going to create. I think it's a bit less convenient, but yeah. Okay, it works, and I think that we're good with the time. So thank you very much. Hey, bravo! Do you still have questions?
Could you, here it's obvious a posteriori, like how to design things the way you present it, but do you have some guidelines on how to approach the problem? And then, so I see at least one, which is try to think of the relationship between your entities, and it makes sense to use class, but do you have some also the list of?
Yeah, maybe say so. In fact, so the solid principles are really important. In fact, and maybe for me the one that really is a light in the dark is the list of substitution principle, because when you ask yourself, okay, everything that I do with object of type B, can I do it with object of type C, and it makes sense. Really, it amounts to asking the good questions. And for me, it's really one of the most important guidelines. And in fact, the other solid principle that we used in the beginning is the what is it? I don't remember which one is it. So single responsibility principle, maybe open close principle. I don't know. Yeah, but essentially the one that says that instead of peeing everywhere in your code with if and then and whatever to do the distinction with the kind of object that you use, just use class and make each object responsible for example, finding its top candidates, generating its string representation, and so on. Because otherwise, And that was in the conclusion of the talk I did on a solid principle. If you see that there are a lot of if-then in your code, and that was what the other Maxime said, if you see that there is a lot of if and else if and whatever in your code, probably you should do class and split all these behaviors into different subclasses of the same object.
I think there is a wide sentence for that. It's designed to an interface, not to an implementation.
Yeah.
And I think it was in a book of Python.
But yeah, I think that essentially that also amounts to one of the solid principles to say that. Yeah. But I would say that once you're used to OOP, in fact, avoiding the first problem that I mentioned, so peeing everywhere with if and else if, comes quite naturally. In fact, if you're a bit used to OOP, you will not do things like that.
But it's everywhere. It's an issue actually. Python lacks of single or multiple dispatch, right? I mean, if in a language where you can, overload a method and have the multiple times the same method with the same name but different type of the argument, and it will automatically choose the one that match, you have less this kind of issue. Right?
Yeah, in fact, I think that's not the only problem, in the sense that if you want to have a method that do similar things, but do we implement it a bit differently for let's say dictionaries, lists, and whatever, this is okay. But in fact, what we have here, and I think it's quite in fact frequent, is that we have several kind of stuff that we might want to represent with the same kind of object, but in fact there is an additional information, which is how do you interpret the list? How do you interpret the dictionary? And what is it supposed to mean?
Yeah,
the
meaning is separate from the internal representation.
Yeah, in some sense. So yeah. You could say, for example, okay, I can have a list that represents my order of preference. I can have a list which is only the list of the subset of candidates that I like, as opposed to the one that I dislike. In fact, if you just represent that by your list, there is a missing information, which is how you interpret that list and how should it be interpreted by all the functions that are going to handle it. And that, I think that you really can solve the problem with type dispatch. In fact, you really need classes to say, okay, yeah, this list represents a linear order, for example.
Some language type alias, right? Say ballot type equal dict. I mean, you can have alias of types. Dict can have several names and dispatch can be named.
But in some sense, you can do it in Python. You could say, okay, ballot linear order is a subclass of list that does nothing, and just you use it with is instance. But
I'm not sure it's
stupid, because you will still have many if and then everywhere in your code you still have the problem of treasure hunt that I mentioned. If you start to do that, do it fully and just implement methods.
Yeah.